have been working on Shinzo since the beginning of this year. And prior to that, I spent 5 years working in the blockchain industry as a blockchain engineer. And so I have a lot of experience working on, decentralized open source protocols. And I think that my experiences from that industry carry over very well into the MCP world. And I think, when I was looking at what projects I was working on at Shinzo, when I first heard about MCP, it really sparked that kind of decentralized ethos in my heart. And I really loved the fact that it was an open protocol that anyone can contribute to. And it was a system that the community was bringing together so that we could have interoperable systems that had a clear foundation for the AI agent revolution that we're going through. And so as I went into the MCP world, I started by building some MCP servers. So I built a few that currently get about 23,000 calls per month. But the big problem that I found was that as a single developer, I did not have any connections with my users who were using these servers. And so I had no idea who they were. I had no idea why they used my servers. And it was not clear what software was out there to actually give me that kind of insight. And so I decided to build an instrumentation solution on top of OpenTelemetry for my own servers. And I then open sourced that so that other developers can use it for their servers as well. And since then, I have built the actual ingest and front-end platform that I'm calling Shinzo Platform. And this allows users to actually import their telemetry straight into our platform, focused on MCP servers, and focused on observability for AI agents in particular. And so I'm happy to share a bit more about the product itself. So I'll go ahead and share here. The main idea behind Shinzo is that we're offering OpenTelemetry-based observability solutions for MCP developers. So the idea is that for companies and for individual developers that are building servers that they want to offer to users, this helps them get insights into knowing who their users are and how they're using those servers. On the dashboard page, you get basic information about how many servers are running, what the tool error rates are like, what the response times are like. And then you can see specific information about the tool calls over time. You can see information about what the user sessions are like and how many tool calls are being run per session. And then down here, you have pie charts, which give you some more specific information about those tool calls. So you can say, for this set of tools, what does the user breakdown look like? And then vice versa, for this set of users, what does the tool call breakdown look like? And so all of this is to help the MCP developers understand more about what is the best service they can offer for their users. And then the last thing down here is that we have, we have latency distribution graph, which allows you to see what the performance is for particular tools so that you can see exactly what your user experience is like. So you know whether there are certain tools that need to have a second look to see if they're actually fitting in that agentic workflow experience, and then which ones you should double down on as very efficient calls that can work well with the agent ecosystem. And then the last thing I'll point out here is that you can also see the specific instances of those servers, and you can see specific data, including the operating system that those servers are running, the operating system architecture, the versions of those servers, so you know if your users are running the latest or if they're running an older version. And then if you have your user's permission, you can also gather some more advanced telemetry, such as the IP address or the geolocation, but only if you have the user's consent specifically. Now, on top of the basic OpenTelemetry data for MCP, we are also exploring other telemetry solutions for the other side of MCP consumers. And so we've recently experimenting with what we're calling spotlights. And so what I'd like to show you is just a quick demo. This isn't live yet, but the demo here shows you a bit about what we envision for the future of observability of AI agents. On the token analytics page, we want to offer the list of models that a user is consuming. So this would be for the consumer of those MCP servers. Which models do you go through? Which MCP client applications are you going through? you get some high-level statistics about the input and output tokens that are going through your agent and your servers. And then you can actually go into specific sessions. So for example, if I wanted to see which session has the most input tokens used, I can come in here and I can see a breakdown of the total requests made through this session, the number of input and output tokens, what percent of those tokens are actually cached, or what relative proportion are cached, and generally how many tool calls were made through this session. And then you can actually dig into those specific requests and responses. So I can see, for example, this one had 11 messages in the request, and the response was right here. And you can see that within this message, we see that there are several tool calls here. And so you can actually dig into those exact tool requests and the tool outputs. And hopefully this will help consumers of MCP understand exactly which servers are consuming the most of their context, and how they can make their servers, how they can consume servers more efficiently so that MCP is a better experience for them. And then on the flip side, if consumers have a better understanding of how these servers are performing in terms of context management and token usage, that will put more pressure on the MCP developers to make their user experience more efficient and just a better overall experience for users of those MCP servers. And so I'm happy to continue talking about, kind of the basis of Shinzo and where we're planning to go in the future, but that's the general overview of the platform that we have today.
Awesome, that looks great. Yeah, really nicely implemented, and seems like something that you put a lot of work into. When did you start working on this product?
Yeah,
Do you mind bringing it back up? Just
yeah,
it'd
absolutely.
be nice to be able to ask some questions and look at it while we're chatting.
Yeah. So the product as a whole, so I started with the instrumentation packages. So I started with TypeScript and then Python because from the developers that I've talked to, it takes up approximately 90% of the ecosystem.
Yep.
So yeah, so we started with TypeScript, built out this specifically for my servers, and then again, open sourced it. And the instrumentation package itself is completely OpenTelemetry compatible. And so you can export this data to whichever OTel compatible ingest service you would like to. So by default, we hope that you would prefer to use the Shinzo platform. But if not, then it's as easy as switching the exporter endpoint right here so that you can send it to any number of the dozens of OTel vendors that are out there. And then down here, you have additional configurations for the instrumentation as well, which includes things such as the sampling rates, PII sanitization, if you believe that your users care about sensitive data on that side. You can have additional data processing before that telemetry is sent to the ingest service. And then you can also choose which parts of the OTel data is actually exported. And so the idea is to put as much power as possible in the hands of the MCP developer, while at the same time not burdening them with too much choice and too much flexibility that they would have to sink their time and energy into.
So I was fascinated with so how far have you gone in terms of the standardizing the structure of the OTel or things like that, or is it like the OTel format is that kind of you would like to see that whatever other people copy it, or it's
so essentially the data model that I'm following is based on the semantic conventions from the OTel working group based around generative AI. And so they have an open PR right now. I don't know if I'll be able to find it, but it's OTel contrib number 2083.
Okay.
An open PR that has standard semantic conventions, which the MCP maintenance team is actually working on trying to merge in so that it becomes standard across the ecosystem. And so we have built on that, optimistically, hoping that this will get in, and then it becomes the standard for what all MCP telemetry is based on. But so far, it's still a work in progress while we figure out which parts of those semantic conventions are essential versus, bespoke implementations.
The other thing, so you showed like token counts and stuff like that, but the one thing that like,
yes, yeah.
where is all this data coming from?
Yeah, so this is intended as a MCP consumer facing product feature. So the idea is that the user would add their model provider credentials. So whether it's Anthropic, OpenAI, or Google, extending to others in the future, you add your API keys here, and then Shinzo will actually give you an endpoint that you then configure your AI apps to connect to, so that it essentially proxies through our service before going to the end model. And so that allows us to intercept the requests and responses, and then pull out that token data.
Okay, so like you're running like for example, like let's see, like Pydantic, they have a AI gateway type thing, which is geared just completely towards monitoring or whatever. Is that kind of like the same thing you're doing here, where it's like you just put yourself in the middle just so that you can have visibility, and that's how you collect this stuff?
Yeah. So the long-term vision is to focus on the agentic components of this observability, because I believe there's a lot of opportunity in the space of context management at the moment, because a lot of users shy away from MCP because they believe it takes up too much of the context window, and they don't know how to call tools efficiently, and they don't know how to build sub agents for specific, toolkits and tool sets. And so I think that there's a lot to be desired on the consumer side to encourage them to use MCP servers. And I believe that by giving them this visibility about what tools are being called and what the context usage is for those tools, it can help those MCP consumers make better decisions about how they integrate that with the agents that they use today.
So for my like agentic application that I'm talking to a model, I'm going to hit the model is going to hit your server. Like instead of me going directly to Google, I hit you, it proxies through, you collect all that. And then is there any type of thing where you can associate the kind of those messages with the MCP? It's a distributed tracing model, right? Like, are you solving kind of that too?
Yeah, so we do not have that yet, but I would love to move in that direction. I think, the main trouble is that with the message data that we get today, it's just focused on the tooling side of it, but it doesn't give you as much visibility into which servers those tools are actually originating from.
Yeah.
And so, from the window of what the model receives, it's just the list of tool requests it wishes to make versus the tools that it has in its tool set. And so there would be additional configuration you have to implement to connect that back to the original server that the user provided. Right.
Yeah, that's what I'd love to see is it's kind of weird because you make a request for the LLM, you get that back, and then you call the tool. So it's not within one span, but it at least has like a parent span or whatever. So it would be somewhat, like I'd love to see that.
Like I would too. And I think I do think it's possible. I think it takes a little bit of that extra effort on the user side to
that's the issue.
Setup.
The client is the one who has to. But you did solve it with the other. You addressed it kind of with the TypeScript library, Python. That's what developers are looking for, just libraries or whatever.
Exactly. Yeah. And so, I don't know where this is headed in the future. The intention, of course, is to continue down the path of surfacing insights on how your agents are working, so that you can build better servers and build better, operable agents. But, we're still in the early days of exploring what that actually looks like.
And this is all a hosted platform, right? So it's running as SaaS. You just connect to the SaaS.
Yeah, so this is all hosted at the moment. I would love to open source it at a reasonable time. It's just I'm still at the stage of experimenting to understand what the correct product form is for users. And so
yeah,
I think I just want to get the first stable version out before I fully open source it.
that's cool.
Yeah, very cool, Austin. And so for somebody who wants to sign up and try it, what's the URL we're going to? It's just Agnos,
Yeah,
or it's Shinzo.ai.
Yep, Shinzo.ai. You
And
should have the ability to sign up directly from the sites. If you want to check out the instrumentation packages, then it has links to our GitHub. So you can check out our TypeScript package here. And then if you want to see the Python one, you just go to Shinzo Labs and then Shinzo-Pi.
awesome.
Yeah.
Well,
And
congratulations, man. This looks really cool. And it seems like you have a really good grasp on the problem. And I think that's half the time, that's the biggest challenge as you're getting going. So congrats on the startup and building
thank
this
you.
up.
And the beautiful
You know,
thing, you can use OTel and all the power of OTel, and nobody has to see it.
Yeah, yeah, that's the thing. Like we handle the complexity of the telemetry, so users and developers just focus on building.
Yeah, that's nice.
Very cool. All right. Well, thanks, Austin.